quantum mechanics is a theory in physics that describes how atoms work and how the electrons surrounding the atoms work. Basically controls all of chemistry, which in the end controls all of biology. So quantum mechanics is incredibly important to understand how the world actually works.
Sup nerds? This project is about quantum mechanics. It's by Dalton Stevens, 8N, Astronomy 2. Prepare to have your minds blown. So, quantum mechanics, also known as quantum physics and quantum theory, is a branch of physics that deals with phenomena at a microscopic level. That's really small stuff, you know. It attempts to provide a mathematical description for behavior and interactions of energy and matter. The earliest versions of quantum mechanics were formulated in the early 1800s, and it was significantly reformed in the mid-1920s by guys like Max Born, a British-German physicist, another German physicist by the name of Pascual Jordan, and a third German physicist by the name of Werner Heisenberg. A lot of Germans up in this field. Here's a short clip about Werner Heisenberg because he was kind of a big deal in the quantum physics field.
Werner Karl Heisenberg was a German physicist who contributed to quantum theory, as well as nuclear and particle physics. Heisenberg was born in Germany in 1901. He was schooled in Munich and then studied physics and mathematics at the universities of Munich and Göttingen. He completed his PhD in 1923, and from 1924 was a private lecturer at Göttingen University. He worked with the famous physicist Niels Bohr, and was then appointed Professor of Theoretical Physics at the University of Leipzig.
By the 1930s, quantum mechanics had been significantly unified and formalized, and it was used to reevaluate a lot of 19th century physics that they found out was pretty much just wrong. A major aspect of the field of quantum mechanics is the search for a theory of everything that could describe the behavior of all microscopic phenomena in relation to energy and matter, and therefore describe how pretty much everything works. However, guys like Carl Sagan and Stephen Hawking have stated that they don't believe that there's a theory of everything, and that there's no way to just cleanly describe how everything works. So in the early 1800s, a double-slit experiment was performed to determine if light was a particle or wave. The first time they did the double-slit experiment, it seemed to prove that light traveled in waves. However, in the early 1900s, it was actually discovered that light traveled in particle-like bundles, but the question was, how did it exhibit the behavior of waves that fooled the past scientists? So they decided to redo the double-slit experiment, but this time using a source that could fire only one photon at a time, and a screen that could detect when that photon hit. Here's the one and only Morgan Freeman from the Science Channel show Through the Wormhole to describe how the double-slit experiment worked.
This simple configuration shoots particles of light called photons, one at a time, through two tiny slits in a screen.
We have a laser which produces light. This light is attenuated such that only one photon at a time emerges. This photon passes through a two-slit assembly, and then we have a camera which registers the pattern behind the two-slit assembly. So what we see is that the photons arrive one by one on the screen, some here, some there, and it looks pretty random.
When they fired a single photon through the slits, alternating light and dark bands appeared, which suggested that there was wave interference. This was crazy because there should be no way for wave interference to appear with only one photon.
The photons travel one by one, some through this slit, some through that slit. You would expect them to leave a pattern of two stripes on the wall. And you would be wrong. They mysteriously create a band of stripes. This is what you would expect to see if a constant beam of light shined through the two slits. It would spread across the wall like a wave. So how can single bullet-like particles of light create a wave pattern? This could only happen if the particles go through both slits at the same time. In other words, the particle is in two places at once.
So the only way this was possible is if the photon was traveling back in time to go through both slits at once. Where it gets really interesting is that if they tried to put a measuring device to see which slit the photon was going through, it went back to normal and just traveled through one slit like they thought it would.
But strangest of all is what happens when you put detectors next to the slits. When the photons are being watched, the wave pattern disappears. Take away the detectors, and the wave pattern comes back. This suggests that we can change the way reality behaves just by looking at it. Does this mean that reality itself is not real?
Now, this discovery implies that photons being observed causes them to revert to a more normal behavior.
The electron decided to act differently, as though it was aware it was being watched.
Now, even though that's super crazy, it's also super interesting. I mean, they may have discovered time travel here. That's so fresh that the greatest series of movies of all time is based around it. If you're living in a box or something, that was Back to the Future. So time travel. Pretty nuts, right? That's not the only crazy thing about quantum mechanics, though. It gets really serious when you get down that small. There's also a little thing called quantum tunneling. This video by Minute Physics talks a little more about what exactly that is.
Suppose you drop a ball down the side of a valley. Classical wisdom tells us that when the ball rolls up the hill on the other side, it can't go any higher than the height from which you dropped it. That's conservation of energy. Even if there's a nice big long slope to roll down on the far side of the mountain, the ball just can't get there, unless you give it enough energy to get over the barrier. But in quantum mechanics, things work a little differently. You see, the quantum world is probabilistic, so if you release a particle in a valley, chances are the next time you see it, it'll still be somewhere in that valley. But if there's a nice big slope to roll down on the far side of the mountain, well, that's a place the particle would really like to be. And it turns out, there's also a small chance that's where you'll find it. If this isn't crazy enough, it's even possible you'll find the particle in the middle of the mountain. And in real life, this means that an electron sometimes hangs around inside the nucleus of an atom.
So both of those are weird. But quantum mechanics isn't just weird, it could also be applicable to really interesting things. There's a little thing called quantum teleportation.
Quantum teleportation is where the specific quantum state of a photon is measured and sent to another location where that information can be used to manipulate another photon into the same quantum state.
In 1998, a photon was successfully teleported about 1 meter. This is cool, but it's not exactly how we think of teleportation. You see, when they teleport something, it destroys the original, so you're just getting an exact copy.
The act of measuring the quantum state of a specific photon will cause that photon to move into a new quantum state. Therefore, the quantum state of the second photon will not reflect the quantum state of the first photon before measurement.
Now, that might seem a little disheartening, but science is moving forward pretty quickly with the whole quantum teleportation thing. In 2002, a laser beam was teleported. In 2012, scientists teleported a qubit, or quantum bit, 60 and then 89 miles. They also teleported the first macroscopic, or visible to the naked eye object, a group of rubidium atoms. In conclusion, quantum mechanics is definitely one of the least understood fields of today. However, it holds the potential to unlock some very interesting things, including teleportation and time travel. Many very intelligent people believe that quantum mechanics holds the secret to the universe, and science continues to progress and understand more as each day goes by.